So this is the electrodes we're using for the conduction study motor. This is the cup like spoon. We're getting conductive media. This is black, and this is red. This is negative, this is positive. So I will getting always the negative at the bulky area of the muscles. And the reference, which is the positive, it will be go far away at the silent area of the bone. I will show it in different electrodes. So this is almost we're using the cup electrodes. Me with this gel, it's almost watery base, and some we use 1020 paste, but I prefer to using another one. I will show right now. This is the other one. The other electrodes is called the ring. The ring, I will use it for recording. This is at the muscles, so I will dealing the motor. This is from the skin, so I will getting sensory recording of the action potential. This is the ring. Ring, it will use for the fingers and toes. Yeah, we can use another technique I will show right now. We have simply using the adhesive one, which is a more popular now in different. This is adhesive one. The adhesive electrodes is very simple. Putting in the muscles like that. And this is another one. Putting the food like so. Okay? And this is the crocodile one. Clipping. This is black and this is red. Black always connected with the black. And red connected with the red. What about if I reverse the connection? Getting the black with the red and vice versa. What are you expecting to get? I will get in the action which what reverse it upside down. Just almost we can get. This is we have to examine in a lot of my students in the 5th grades of the faculty of physical therapy. If we can just reverse what you can expecting from this waveforms. Or I getting waveforms but inverted. So what about the artifact? What about the error in recording? Simply we getting reverse the black at the red and the red. Yes. Okay. So this is the black connected to the black. Black is the negative, red is the positive. Black is an active to record the action potential. Negative is a silent to reversing it to the its normal resting membrane potential. So this is the stimulating. The same. We having a positive. We having negative. This positive is the anode with the which is the negative is the cathode. Always we're getting the negative toward the negative in motor. Negative toward the negative. Negative toward the negative. Negative toward the negative. What about if reverse? Positive toward the negative. We will get excessive ion accumulation under the positive. This positive icons with the positive charges leading to what's called anodal block, not good propagation of the action potential to reaching the active. So the mean practically and theoretically you can say if we're getting stimulation with the positive, I will getting a nodal block. It's not properly to use this technique, but I would use obviously the negative toward the negative. Take this home message. All with the action potential you can get the upside negative action potential starting from the negative to the negative of the active. Let's see. What about the distance? The common error in conduction study is the measurement. The common error in conduction study is the measurement. How? It must to get 8 centimeters to getting 6 to 8 centimeter to getting the active like here. What about if getting a 10? The distance it will be increased. So the latency here, it will be increased. It will be getting a false impact about I have increased the latency distally at the rest. But the problem is the not correctly placing the stimulation. Simply. So the measurement is crucial to getting a impact about what about the value I will get from the stimulation. So I will get at 8 centimeter or 6 centimeter, depending about the length of the. Do not forget the whole length of the median nerve. I'm talking about the median, I'm talking about the ulnar, I'm talking about the radial, which is the three components is the lung. What about the musculocutaneous? With the biceps is very short. This is the musculocutaneous. One single shot. What about the axillary? One single shot. I'm not dealing with the long one. So I will refer to the other contralateral side. This is the median. Briefly, I will explain what about I will do for this patient. Please, I will get in some unpleasant sensation. I'm not always using the electrical impulse, shock, just unpleasant sensation like you have the tingling. You will get, I will start almost the motor at 10 milliamp. Why? This is adjusted at the machine. Why at 10? It must to exceed the sensory threshold. Sensory threshold, I will dealing with the sensory component only. From 5 to 20 milliamp, I'm dealing with the sensory component. From 20 to 50 milliamp, I will dealing with the motor. So let's go. I'm dealing till 13, from 5 to 20, I'm dealing with the sensory. So 13, I'm dealing with the sensory, still sensory. So I'm getting this almost, I'm getting this response, which is the CMAP, conduction, compound muscle action potential. This is an action potential. This is the depolarization, this is the repolarization, this is the hyperpolarization area. So what about this? I can accept? No, it must to exceed a little bit. Getting more and more increase of the amplitude. What I mean, I'm getting another shot for the another axons. So I'm getting another axons? No. I'm getting another axon? No. I'm sure now I'm hitting all the axons distally at the wrist. So if we get hitting excitation, stimulation, electrical stimulation for the all axons at the wrist, I will getting all muscle fiber, all or none lobe. So now I can accept. This is the supramaximal stimulation. It must to be get supramaximal stimulation for this patient. Okay. What about the second stimulation? The second stimulation, I will show a guide for different techniques for this patient very, very simply. For the median, for the radial, I will getting also some reference for doing this. But this is an introductory course, and this I hope in short future I will getting another in-depth clarification. So this is the proximal component. Great. What about? Great. What about this increased? Yes? This median nerve here is more deeper than the wrist. Yes? If we're getting compare superimposed the distal and the elbow one, what you can notice in this amplitude? Let me show in another way. Let me see what about the amplitude I get. The amplitude distal is 9.5. The amplitude proximal is the 8.9. So it is reduced rather than the distal. So I can take it as an abnormality or no?
No. It's more deeper.
Why? So what about the physiological clarification for this? Phase cancellation. In more depth of the median nerve, some fibers getting negative charges, some fibers getting positive charges. And the same speeds, so the positive and negative same speed, it cancel to each other. So we can accept reduction in the proximal stimulation rather than the distal stimulation. Normally till 10% I can accept. Okay? So, can we clarify it very simply? Yes. I can, in the 12, in the table right now, we're getting for this normal patient reduction of the amplitude proximal rather than the distal. So, I'm getting with this patient, please, can do a reduction of this patient? Yes. Can do the thumb, abduction, abduction. What about the strength? Very good. Intact. So ignore. If we have a reduction in amplitude associated with a weakness, we can take it as abnormality. If we're getting a conduction block or reduction of the amplitude without motor deficit of the distal muscles, this is the technical error. So I'm getting two home messages right now. The first is the phase cancellations. The second is the measurement. The third is the any conduction block, a reduction of the amplitude without any motor deficit, it must to be ignored. The third one is the R1. So, what about stimulus effect? What about? What about? Can you get some conductive media? What about? What about? What about? No more increase. Severe reduction of the amplitude like here. A relation for this. Let me superimpose. It's more than, I think, 4.7. The normal is the distal 9. So it is reaching to the half. So normally it must have a deficit. This is a technical error. I will correct this. I will delete this. I will getting some improvement for this. With this, just keep. Can get some improvement. You have, yes. I'm very sad for your Chuck, dear Islam. Ratherly, what about very good amplitude? Yes?
Yes.
What about, I will do getting some little bit medially stimulated the ulnar nerve falsely. If we're hitting properly on the medial nerve, I will getting the normal response, and this, what's called linear change. What? Linear change. If we're getting non-linear change, I'm out from the nerve. Of course? Yes. So, the second one, I will getting the measures. Okay, we have a measure here, and getting conduction velocity at the distal part. I will getting the difference between the negative, and we're getting the distance here, getting the conduction velocity. The conduction velocity is the conduction velocity from the proximal stimulation from the negative till the negative, and the distal from the negative till the negative. I will take the forearm part. So time, the distance divided by the time, it will get in the conduction velocity. So the machine getting this very simple. I'm getting the negative from here to negative from here is about 20. I'm getting here 20 centimeter. But this machine getting the measurement here. Yes, measurement here from 4 millimeter. So I will get him 200 millimeter. It's at 20 centimeter. This is okay. Getting the conduction velocity. The conduction velocity now is 59.5. The normal of this machine is the 60. So the patient have actually normal. This 0.5, it's not the main abnormality. So patient have latency 2.8. The latency distal is very important, especially in the more interrupted side. At the medial nerve here can be getting carpal tunnel syndrome. At the ulnar here I getting Cohen tunnel syndrome. At the radial, if recorded from the extensor indicis proprius, we haven't anything can trap this radial portion at this area. So I can ignore the distal latency at the medial nerve, at the radial nerve, sorry, but I can take the radial nerve at the proximal part at the supinator level, so the supinator underneath the arch of Roche can be trapped as a posterior interosseous interopathy. Okay, so this is, for example, the medial nerve. So I getting 1, 2, 3. I have just the last one, which is the ERP one, which is a very painful. The ERP one related for the sternocleidomastoid and the upper tram, we have an angle. A little bit. What about this? It's away. Yes? This is a volume conduction. So I can not take this as the previous one. This is not almost matching linearly. So I will delete it. Okay? Again, I will reduce. Yes. This is matching with the all waveforms with the
Linear.
yes, linear. So the distance distal 8, the distance proximal 20, the distance here it will exceeds the distal here from the far away abductor brevis. So if we have getting more and more proximal stimulation, the latency it will be increased, but in a linear yes manner. Okay. Always the motor, it is a good friend with the linked one, which is the if. Which what about if? Let me again getting this is the whole median. So I'm getting study about the median nerve at its terminal path, terminal branches, this part, and again I getting a good idea about what about this median fibers across the elbow. I getting the data. The second one, what about the median nerve across the mid-arc? I getting data. What about the median nerve across supraclavicular? I getting the data. What about the root? I don't know. Yes? So I will get a data, but this need some another clarifications, which is the if wave. The if wave is the more proximal part of the. What about this? This is the EMG trace, which is the patient. What about the patient? It's rested or it's an excited? It must to be good rested patient. Yes, great. So I will get supramaximal stimulation to hitting the alpha motor neuron ball. This alpha, this F wave hitting the alpha motor neuron ball. What about the time? Yes. The alpha motor neuron ball, every single stimulation getting 5% of the alpha motor unit and getting a action potential. The other one dealing with the another 5% of the alpha motor neuron. The third one getting another 5% and so forth. So I will get this. This is an M. This M, it's exactly this distal M. At the wrist, this is the distal M. This is the M recorded from the abductor pulse brevis. Okay? Yes, again, this is the M. But we haven't any component of the F, which is backfired from the roots to getting picked up from the active one. We have no F wave, so I will getting supramaximal stimulation. What about? Getting F wave, yes. What about? I getting F wave. What about? I have. So I will create to be getting supramaximal stimulation. I will dealing with the second button, which is multiple. So let's go. 3, 4, 5, 6, 7, 8, 9, 10. I can now stop this